Hello, everyone. Let's talk about oxidations. The mechanisms are kind of long. I'm going to try my best to go as slow as possible and color code as many things as possible. And so let's go ahead and get started. Let's talk about Swern oxidation. Swern oxidations, remember that the overall predicted product is that primary alcohols will go to aldehydes. So from here, this is a primary alcohol. We'll make an aldehyde. And the secondary alcohols will make ketones. And so we'll go ahead and we'll start. We're going to go ahead and we're going to take uh, this right here, right? This is Cocal 2. I'm sure it has a more formalized name, but I call it Cocal 2. And this is DMSO right here. This is going to be used later. But before we actually even touch the thing that we want to oxidize, we're going to go ahead and do some preparatory steps going forward here. And so let's start off with the preparatory step, right? It's going to be step to phase one, I would say, right? So phase one, we're going to go ahead and we're going to do this. This makes this S plus charge right here. And when that happens, right, our one little guy over here move in to attack here. This will then pop up here, right? And so you're going to have this right here. Alrighty. And then when this happens, right, this guy will come down here. This will pop off onto its own. Yep. Alrighty. And then from here, right, this chlorine will go. It'll tack onto here. And then this will pop off as a response. That is the chlorine that we kicked off last part, in the last step. Alrighty. And then from here, you're going to end up with this. End up with this. I'll start here. Right. And then you're going to end up with oxygen. You're going to end up with the other product of this. It's going to be this. Alrighty. Cool. I'm going to go ahead. I'm going to box this up. Right. We're going to use this for later. So save this. Right. Will be used later. We're going to go and continue on and like resolve these byproducts over here because Dr. Ko decided that it's going to be important for us. And so if it's important to him, it's important to me because I'm teaching you it. Alrighty. So from here, we'll come onto here, and this is going to pop off in response. You're going to end up with this over here. This is going to be CO2. Right? We're going to end up with this. This is going to come back down onto here, popping this off. And then eventually you're going to end up with your byproducts. Byproducts. Yeah, so cool. Now, why is this important? Well, it popped up on one of my exams the time I took this class. So yeah, byproducts of sworn. Yep. Okay, great. So let's move on to the next step, right, where we actually do the actual oxidation, right? We're gonna go ahead and we're gonna take this thing down with us. All right. All right. So let's go ahead and let's bring the thing that we actually want to uh thing that we actually want to oxidize down here. So since S has a plus charge on it, this is naturally going to attract this guy over here. And when that happens, we're going to end up with this. Cl. End up with this here, right? That S is going to lose its plus charge because it's happy, formal charge wise. And then from here, right? The Cl from the byproduct over here, right? The Cl that was up here, right? The Cl is going to come. I'll go ahead and I'll highlight this in a different color for you, right? So you don't get confused. Highlight this in pink. Cl will come over here, do a quick proton transfer onto here. It's going to pop down onto here. Alrighty, cool. I'm gonna go ahead and draw out the H's here. It's gonna be relevant in a second. And then from this point on, right, the ET3N will actually come into play here. This ET3N up here. This ET3N. If you're confused, pause and just rewatch the video again. I'm so sorry if this is kind of complicated because it is. So I don't blame you at all if you feel very, very confused. All right. So this ET3N, right, is going to find one of these H's that is on the little sulfur molecule that came in earlier, right? And oh, it's gonna be this right here. Oops. Going to go in. It's going to do a quick proton transfer. Going to grab that. This is going to pop onto here. And then I'm going to draw this very carefully. You're going to end up with the CH2 here. All right. All right. Cool. And this ET3N is going to be chilling on the side. It's one of its proton that it stole. Okay. So then from here, right? This is going to be one of those similar to MCPBA. You're going to have attack onto here. This is going to pop onto here. You're going to form that double bond, and then this is going to pop off on its own. And from here, you're going to end up with this. CH3, Cl, and then you're going to end up with, finally, your product. It's going to be an aldehyde. Yep. And to kind of quickly help illustrate this to you, right? Make sure that you're not confused, right? This H, how we got a CH3 back again on this end was because of this guy right here. These are the same hydrogen. Like this. Let's see yellow. Maybe that's not the best color. I'll make this white. Yep. So yeah, there you go. Aldehyde. Oops. Okay, let's triple check, right? We started off with a primary alcohol, yes? That is a primary alcohol, and we made an aldehyde out of it. So yeah, that's the mechanism for swearing. Let's go on over to PCC. So the PCC mechanism is, I want to say, pretty straightforward. PCC and PDC are very, very similar. So the notes focus on PCC, so we'll do that. Alrighty. So with PCC, it's relatively straightforward, I would say. The first step is that this guy over here moves in and attacks this, and then this pops this guy up on here. It's going to pop up on its own. All right. And then in response, it's gonna pop back down onto, whoops, I overshot that, down to here. Seal's gonna pop off in response and leave. These mechanisms are long. Pause if you need to take a break, go to the restroom or something. And my iPad just crashed. Give me 1 second. Let me just reboot it. We're still screen recording on this end? No, we're not. Okay. Let me go ahead and redo this. It happens so often, especially when I'm recording for a long time. All right. Cool. Alrighty, we are back at it. And my audio is okay? My audio is okay. Awesome. Cool. So from here, right, what's going to happen is that you well try to regain my bearings here after I got shut off. Anyways. Yes. It's gonna pop back off onto here. And then this guy over here, right? I'm going to do a quick photon transfer right here, pop off onto here, come back down, right? It's going to lose its charge because it's chilling now. H here. Yep. And then we're going to have I'm going to go ahead and we're going to have one of those multi-step ones again. Something here, that's going to grab that. This is going to pop off onto here, and then this is going to pop off onto here. And then voila, have an aldehyde. Alrighty. Cool. I do this a little awkwardly angled, but yes, this is basically the you get a reduced chromium, and then you get an aldehyde up here. Right, PCC and Swern basically have the same outcomes for both primary and secondary alcohols. Okay, cool. From here, whew, man, we're gonna move on to the Jones oxidation. This one's a little different because, well, first and foremost, primary alcohols with Jones turn into carboxylic acids. Secondary alcohols will always turn into ketones no matter what. And so, for the Jones oxidation, we're gonna do the more complicated one, the carboxylic acid. And so, yeah, I would say just kind of prepare yourself, right? It's kind of long, and yeah, we'll go ahead and we'll get started with these guys, right? We're gonna use sodium. We're gonna use sodium. I'm a big fan. We're gonna race against the clock until my iPad crashes again. So we're gonna do that. We'll go ahead and highlight this different color, right? Alrighty, cool. So here's what that looks like. Make sure I count for all of the. That's 2, 3, 4, 5, 6, 7. Negative. If here, right? Na plus, Na plus. Right. And then we're gonna have two of these guys up in here. This is gonna be phase one. Yeah. Split the reaction up at phase one. Alrighty, so what's going to happen from here is that you're going to do, I'm not going to draw this all out, right? But you're going to do proton transfer twice because we have a strong acid here, sulfuric acid, and we have these guys over here, right? And so we're going to get this. Maybe asking yourself, how are you, like, if this is such a long, like, mechanism, how do we memorize it? Well, my secret was I just sat there, I just drew it over and over again until it stuck in my head. So, works out. Yeah, okay, cool. Alrighty. And so the first preparatory step here, right, is that we're going to attack onto here. This is going to pop off right here. So this is going to come onto here. You're going to get this. Hmm. Right here. It's right here. This is going to split up into two. And so there's going to be a quick distinction between these two right here, right? But this is this part right here. And so I'm going to go ahead. I'm going to highlight this in a different color so you can kind of see that a little bit more clearly here. I'm going to highlight this in pink, right? And so the very quick thing about this pink thing is it's going to go onto here. And then this is going to go off and find an H. This is a super, super abbreviated proton transfer, but you're going to end up with this. Chromium right here, chromium right here. Right? You have an H2O here. Yep. Byproducts here. Mhm. Lovely. And so from here, right, we basically finish the first phase. This is the preparatory phase. We're gonna move on to the second phase over here, right? I'm gonna go ahead, I'm gonna bring this guy down here. And now we're finally going to bring out our our actual thing that we want to react with. And so we're going to grab this bad boy over here. This is the same one, right? Lovely. All right, cool. To tack onto here. This will pop off right here. I'm going to have to shrink this a little bit so I have more space. It's going to come on over here. And I'm going to flip this around. And end up with this. Okay. And then from here, you're going to do a quick proton transfer to get rid of this guy right here. I'm going to do this for the first time, right? But you can basically just use any base, any generic base from here. And but at this point, I'm just going to put PT to indicate proton transfer because I don't want to draw everything out again. Uh, it's going to be chill here. I'm going to make this right here. And then from this step, right, we're going to have essentially one of those uh multi-arrow steps. Yeah. So this guy is going to go ahead and grab this H right here. I probably should choose a different color. Grab this H right here. This is going to come down onto here. Then this guy over here is going to pop off as so. All right. Cool. And so from here, going to have H. We have this guy right here. We have this guy right here. H. Alrighty. Add this onto here. Right. You have an aldehyde. We're not done yet, right? Because we established that primary alcohols go to carboxylic acid. This is not a carboxylic acid. So from here, right, we're going to take that aldehyde. We're going to go to the third step. Do I have space? Oh, hell yeah, I do. Heck yeah. I'm going to take this aldehyde, right? And then first thing that's going to happen to it is that this guy is going to get proton, one of the waters that's kind of just floating around. I think it's safe to assume that like you basically are doing a lot of these reactions in aqueous solution, so you're chilling. You just say there's water, water everywhere. All right. So once this happens, right, uh, from here we're going to get another water, right? I'm going to indicate this as another color. This is important, right? Because now that like we have no with plus charge here, it's going to attract this red one right here. It's going to move in here. It's going to pop off like so. So you're going to end up with a, I believe that the name of this is a geminal diol. Yeah. I could honestly care less for names, so who cares? Just make sure I'm seeing it right. Cool. Sweet. Alrighty. So we're going to have this, and then you're going to have this guy right here. Plus charge, right? Because formal charge is kind of pissed off. And so from here, we're going to do a quick proton transfer. Just use any generic base. That works. You just write out the word base and use that. Right. Probably best to draw this out. And then, right, the chromium from earlier, right, the one all the way, where is it? Wait, that's just going too far. The one all the way up here, right, that we set aside for a second, this guy right here, is going to go and make an make an entrance. And now we're going to go and we're going to go ahead and we're going to do some chemistry with it. And so it's going to tack onto here. It's going to pop off like so. And you're going to end up with this. All right. And then from here, there's an H that's here, right? It's an implied H. Hopefully you guys are familiar with that by now, right? There's an H there from an aldehyde. And then it's going to go into here, attack onto here. It's going to pop off onto here, right? And then this guy will pop off right here. It's going to be another one of those multi-step ones. Let me just make it a little more clear. I'm not satisfied with how small that is. Oops. Mhm. And then from there, you're going to go ahead and you are going to have this. We're gonna have an H here, right? Obviously. But there, this is your carboxylic acid, right? You can just do a quick proton transfer to get rid of it, of the plus charge. But yeah, boom. And that, people who are watching, was the Jones oxidation. So hopefully this was helpful. This is all the oxidations that you mainly need to know for the class. And I hope that was helpful. And please find me if you have any questions. Good hunting. See you around.